So today we're going to talk about balancing chemical reactions. The reason why we balance chemical reactions is because of the law of conservation of mass. And that tells us that mass cannot be created nor destroyed. So what that means as far as balancing reactions, it means that we have to have the same number of each element on both sides of our reaction arrow. The left side of our yield sign, remember the arrow is our yield sign, are known as our reactants. The right side are our products. So we have to make sure that we have the same number of all elements on both sides. Now, we always want to start from our left and work our way right. And if we notice a polyatomic ion, we can actually take a little bit of a shortcut. So here we have a polyatomic ion of NH4. If we have NH4 together as a polyatomic ion on our product side as well, then we don't have to separate them. We can actually keep them all together. So here I have 2 ammoniums, and I only have 1 ammonium on this side. While we are balancing, we are only changing something called coefficients. Coefficients are out in front of each individual particle. So here we have 2 ammoniums, but on this side we only have 1, so we can put a 2 coefficient out in front. So now we have 2 ammoniums on this side as well. Next up we have sulfur. I have 1 sulfur on my reactant side and 1 sulfur on my product side, so that's already balanced. Here I have 1 sodium on my reactant side, but 2 on my product side. So I'm going to have to put a 2 coefficient out in front of sodium. Now this 2 coefficient is going to apply to everything that is part of that compound. So now I have 2 oxygens that are on my reactant side, and I also have 2 on my product side, so that's good. Now, I don't need to worry about the hydrogens that are part of ammonium because those were already accounted for here. So now I'm just looking at the hydrogens that are not part of ammonium. So I have 2 that are not part of ammonium and 2 that are not part of ammonium, so I'm good. Now, as long as you have the same number of each element on both sides, then you are balanced. So that one is good. Let's go on to the next one. Again, when we are balancing, we are only changing coefficients. So I have 3 potassiums on my reactant side, but only 1 on my product side. So I have to put a 3 out in front of potassium. Now I have 1 nitrogen on my reactant side, but 2 on my product side. So I need to put a 2 out in front of nitrogen. Now whenever you put a coefficient in front of a compound, you have to see if you change anything else. When I put this 2 here, I changed the number of potassiums I had. I now have 6 that are a part of here, right? Because I have 3 potassiums for each, but I'm saying that I have 2 of them. So since I now have 6, I need to go back and change that 3 coefficient to a 6. And now I am balanced. Let me go to the next one. I have 1 aluminum on my reactant side, but 2 on my product side. So I need to put a 2 out in front. Next up, I have oxygen. For every aluminum hydroxide, I have 3 oxygens, but I have 2 of them, so that makes a total of 6 now. Now I have 3 over here and 1 part of water. So I know that I need to have an additional 2. I need 6 total. So I'm going to put a 3 out in front of water. Now I have 6 hydrogens on my reactant side and 6 hydrogens on my product side. Now I'm all balanced. This here is a type of combustion reaction. Now when doing combustion reactions, I actually approach them slightly different, but they start off similar. So we start from our left and work our way right. I have 3 carbons on my reactant side, but only 1 on my product side, so I'm going to put a 3 out in front. I have 8 hydrogens on my reactant side, but only 2 on my product side. So I need to multiply the 2 by a 4 to get 8 hydrogens. Now I notice that my oxygens on this side are in multiples of 2. So I know that I'm going to need some sort of even number on this side. If I add up all the oxygens, I have 3 that's part of CO and 4 that is part of water. So I have a total of 7. We know that we have to divide this number by 2 in order to get the coefficient that goes in front of O2. When I do that, I get 3.5. This number can be your coefficient that goes in front of oxygen, but we cannot have a half of a compound or half of any particle, whether it's a compound or an element. So in order to get rid of that 0.5, we need to multiply every single coefficient by 2. So this coefficient was a 1, so now I need to put a 2 out in front of it. 3.5 times 2 is 7. This becomes a 6, and this becomes an 8. Now a good way to make sure that you're doing this right is by checking your answer. So now I have 6 carbons on my reactant side, I have 6 on my product side. I now have 16 hydrogens on my reactant side. I also have 16 on my product side. I have 14 oxygens on my reactant side. Then I have 6 plus 8 gives me 14 as well. So I am good.